Hello friends, welcome to our new lecture series on STADD Pro Connect Edition. Today in this video we will see how to model and design a continuous beam subjected to a given loading conditions. I hope you all are enjoying this lecture series. Subscribe to my YouTube channel so that you can get updates of my latest videos on STADD Pro Connect Edition. Share my YouTube link to your friends and ask them to subscribe who wishes to learn STADD Pro for free. So in this video, let us first see the problem statement and then we will move to our modeling part. So this is the problem statement. We want to analyze and design a continuous beam for the given loading condition using STADD Pro Connect Edition. So here you can see we have a continuous beam whose one end is fixed and another end is hinged, and this beam consists of this continuous beam has three different spans of 5 meter, 6 meter and 4 meter. We have three different types of loading conditions also. One is a point load of 20 kilonewton which is acting at the center of the span 5 meter. Another loading is of UDL of 10 kilonewton per meter acting on the entire span of 6 meter. And the third is an external moment of 5 kilonewton meter acting at the center of the span of 4 meter. So we will first model this beam in our STADD Pro Connect Edition and then we will analyze it, and also we will see the design part of it. So let us move to the STADD Pro. So here you can see this is the working interface of the STADD Pro. Again, in this case we will first move to our configuration, and here in the configuration we will see some basic changes. So we will see the base unit in this case is metric, so it is in the metric, and in the global axis is in the Y up. So these are okay. Then we will close this and then we will move to this option new, because we are going to model a new structure in this case. So let us click on this new. So here we will need to give some model information. So we will give the file name. So let us write the file name as continuous beam, and the location I have told you in the earlier video that we will make a folder in our own computer and we will try to save all the files as well as the supporting files of the STADD Pro in the same folder. So here you can see I have created a folder in the desktop with a name STADD, and in that STADD folder we have made a different folder naming continuous beam, and all the files will be stored in that folder itself. Here you can see the unit is metric, and after all the configuration we will click on this option create. So it will be directed to a new window, and this is the working interface of the STADD Pro. Now as per the problem statement, we have a beam of 15 meter. Overall length of the beam is 15 meter, and out of this 15 meter we have three different beams of 5 meter, 6 meter and 4 meter. So as stated earlier that we will first create nodes and then we will add beam from node to node. So our first node will be at the origin. So here we will click 0 and click enter. So Y and Z will be automatically taken 0 in this case. Here you can see a node has been created. Now the second node is at a distance of 5 meter from the origin. So let us write 5 in the X coordinate and let us click enter. So Y will be 0 and Z will be 0. Here you can see another node is created at a distance of 5 meter from the first node. Now the third node is at a distance of 11 meter from the first node. So we will click enter and the third node is created, and the last node is created at a distance of 15 meter from the first node. So here you can see the four different nodes have been created. We will click on the view option here, and I have told you initially, if it is disabled, click anywhere in this white zone and it will be highlighted. Now here you can see we can click on this front view and we can see this, all these 4 nodes are visualized in the front view option, and these are the nodes, the nodal distance. Now we will add node to node in this case. So for that we will again go to geometry and we will click on this add beam option. So let us click on this add beam option, and then we will click from node to node. This is the first beam, then from second node to third node, this is the second beam, from third node to fourth node, this is the third beam. So here you can see we have created 4 nodes and we have created 3 beams. And let us click the escape key in the keyboard. We will be out of this key. Now beams have been created and nodes have been created. Now we will move to the properties first. Now in this problem, the properties or the section size of the beam has not been given, so we need to assume it, and we will try to analyze it based on that assumption. So let us see that. We will first click on these properties, and here we have to go to this define tab, and let us click on the rectangular beam. We are assuming that the beam is rectangular in shape and we need to give some section properties and the section size. So here YD and ZD is required. Let us write YD as 0.45 meter, that is 450 mm, and we are taking ZD also 450 mm as per our assumption. Click on this add option and close. Now here you can see this rectangular section of 450 mm cross 450 mm has been added, but it has not been assigned yet. So we need to assign this section to the beams. So currently we have 3 beams in our case. So this is the first beam, this is the second beam, and this is the third beam. And as per our assumption, all the beams are of the same size. If you wish, you can change the dimension of any other beam and then you can assign accordingly. Currently I am taking the single size of the beam, and I will assign this size to all the beams in our case. So let us select all the beams and we will use this assignment method, that is assign to the selected beam. Now to select the beams in which you have multiple options, there are different ways of selecting. First is that you drag your mouse in such a way that all the beams are selected at one go. So by pressing the mouse and dragging the mouse in such a way that your entire beam is under this rectangular selected window, and just leave this, you will all the beams will be selected at one go. Another option is that use your control key in your keyboard and select one key one by one. So there are 2 ways in which you can select it. So now all the 3 beams have been selected, and here this section is highlighted, and this is the assignment method, that is assigned to the selected beam. We will use this option assign. The computer will ask you whether you want to assign it to the selected beam. Yes, I want to assign, and click OK. Here you can see the rectangular section 1 has been assigned to all the 3 beams. Now we will move to the support part. Here support. Now in our case we have 3 different types of supports. One is fixed support, another one is hinge support, and third one is roller support. So we will create that types of support first. So this is fixed, let us add it. Here you can see this support has been added. We will again create pin support, we will add it, and we have a roller support, and in the roller we use this option, that is fixed butt, and in the fixed butt option we will release fx, fz, mx, my and mz. Click on add, and here you can see 3 different types of supports have been added in your database. Now we need to assign this support to the assigned nodes. So this is the fixed support, and the fixed support has been is to be assigned here. So we will first select this node. Here you can see, if you drag your mouse closer to this point, the node which is there will be automatically get selected. So this node is selected, and this is the node which I have taken. This is the fixed beam, fixed support, and we will use this option assign. So this fixed support will be assigned to this node. Now we have a node here, and that the support for that is the roller. So just drag your mouse closer to this point, and here you can see this node will be selected. And this is the support that I have chosen, and this is the assigned to the selected node. I will assign this roller support here. Now we know that we have two nodes here. Just drag your mouse in such a way that two nodes will be selected. If you drag your mouse like this, only one node will be selected. So if you drag your mouse in such a way that two nodes are within this rectangle, then two nodes will be selected at one go. Just leave your mouse. Here you can see two nodes have been selected, and this is the support. So we need to check this support first, and then we need to choose the nodes and then assign. So here you can see one fixed support has been assigned here, one roller support has been assigned here, and two pinned support has been assigned here. Just close this. So after supports has been assigned, now let us move to this loading option. So let us click on this loading. Now we have to first define the load case details. So let us click on this load case and then click on this add option. So this is the load case, and we have to first define our load cases. So let us first define the dead load, and title we will write dead load. Click on this option add. Here you can see first dead load has been added in the load case detail, and the second loading type is live. Let us write this as live load and click on add. Let us close this. Here you can see two different type of load case details has been added. One is dead load, second one is live load. Now let us click on the dead load first and then click on the add option. Now we have to add the self weight, because we all know that dead load is a self weight. So we will add the self weight here. So self weight is in the global y direction, and the factor is -1. So it will act in the -y direction. So we will add this. Let us close this. Here you can see the self weight in the -y direction has been added in the load case details, but there is a question mark here. So we need to assign this self weight to this beam. We will do it later on. Let us first add the live load. So let us click on this live load and click on add. Now in our problem we have three different types of loads, out of which one is a point load, second one is uniformly distributed load, and third is an external moment. And all these loads are member loads. So we will go to the member load first, and in the member load we have various options here. So first we will use this uniform force. So uniform force, the value is -10 kilonewton per meter, and this is acting throughout the span. So in that case we will use 0 0 0 in d1 d2 d3, and the direction is global y, and the load is -10. Minus signifies that the load is acting from top to bottom. Let us add this. So here you can see this uniform force of -10 kilonewton per meter has been added, and there is a question mark here. That means it has not been assigned yet. We will assign it later on. First we will add the other two types of load. Another load is a concentrated force. So after supports has been assigned, now let us move to this loading option. So let us click on this loading. Now we have to first define the load case details. So let us click on this load case and then click on this add option. So this is the load case, and we have to first define our load cases. So let us first define the dead load, and title we will write dead load. Click on this option add. Here you can see first dead load has been added in the load case detail, and the second loading type is live. Let us write this as live load and click on add. Let us close this. Here you can see two different type of load case details has been added. One is dead load, second one is live load. Now let us click on the dead load first and then click on the add option. Now we have to add the self weight, because we all know that dead load is a self weight. So we will add the self weight here. So self weight is in the global y direction and the factor is -1, so it will act in the -y direction. So we will add this. Let us close this. Here you can see the self weight in the -y direction has been added in the load case details, but there is a question mark here, so we need to assign this self weight to this beam. We will do it later on. Let us first add the live load. So let us click on this live load and click on add. Now in our problem we have three different types of loads, out of which one is a point load, second one is uniformly distributed load, and third is an external moment. And all these loads are member load. So we will go to the member load first, and in the member load we have various options here. So first we will use this uniform force. So uniform force, the value is -10 kilonewton per meter, and this is acting throughout the span. So in that case we will use 0 0 0 in d1 d2 d3, and the direction is global y, and the load is -10. Minus signifies that the load is acting from top to bottom. Let us add this. So here you can see this uniform force of -10 kilonewton per meter has been added, and there is a question mark here. That means it has not been assigned yet. We will assign it later on. First we will add the other two types of load. Another load is a concentrated force. So here you can see this is the value of the concentrated force. So we need to give the value of P. So our value is -20 kilonewton, and d1 is the distance from the edge to the point of application. One can visualize this from the figure. So in our case this point load is acting at a distance of 2.5 meter from the fixed end. So we will write d1 equal to 2.5, and d2 is 0 in our case, because d2 is acting at the center of the beam. So cross section. So we can say that d2 is 0 but d1 is 2.5 and the direction is global y. Let us add this. And the third type of load is the concentrated moment. Now the concentrated moment, the value is 5 kilonewton per meter, and d1 is 2 meter, d2 is 0. But we have to understand the sign convention of STADD Pro. The sign convention is that in STADD Pro the clockwise moment are taken as negative and anti-clockwise moment are taken as positive. So in our case we have been given an external moment of 5 kilonewton meter, and this is a clockwise moment, so we will use here -5. Moreover, the direction of the moment is in the global z direction. We have to understand this from our structural point of view, that when the loading is on a vertical plane, that is on the xy plane, the moment will always be created along z axis. So we have to check this direction to global z and then add and close. So here we can see that various types of load has been added in the load case details, but these loads have not been assigned yet. We have to assign these manually to our structure. So let us first click on this self weight. Now self weight will be added to all the beams, so we will select all the beam at one go. So drag your mouse from the corner so that all the beams are selected at one go, and we will select this self weight, and we will use this method, that is assign to the selected beam. So first click on this assignment method and then click on this and click on the assign. The STADD Pro will ask you whether you want to assign this. Yes, I will assign this. Here you can see the self weight has been assigned to all the beams and the question mark is removed. Similarly, unselect this first. Now this is UDL. So UDL is acting at the second beam here. So first we will select this beam and we will use this method, that is assignment method, assign to the selected beam, and then check on this and click on assign. Yes, here you can see UDL has been acting on the beam. Similarly, this is point load. So first we will unselect this, we will select this beam and we will click on the assign to the selected beam and check this option and click on assign. Here you can see a point load has been assigned here. And third is, we will, now one thing you have to understand that currently this beam is selected. So whenever you are having a multiple number of loading cases on multiple number of beams, make sure that whenever you are selecting some of the load or beam, you should unselect everything. For an example, here this beam is already been selected. Now if you click on this and then you click on this, then sometimes this beam remains selected. So make sure that the loading has been assigned to the given beam only. So we have selected this beam and we have used this selected beam and we are using this moment assigned. Now all the load has been assigned here, but currently we are here, we can see the UDL, we can see the point load, but we are not able to see the moment. We will see this how we can visualize that. Let us first close this tab. Now this is the loading cases, so we can go to this loading option and we can again click on this live load. So this is the point load and this is the moment. Now let us right click on this part, and when you will right click on this part, you can go to this level option, level. Another way of going to this level option is that you go to this select view tab, and in the view tab you can have this level setting. So either click on this or you can right click on the portion and then you can move to the level setting. Now in the level setting there is an option called scales. Here in the scales we need to adjust this scaling factor. So for that first check on this box, that is apply immediately, and for an example this is the 0.4, so we will increase this 0.4, and here you can see this arrow has now been adjusted. Similarly, if you increase this distributed force, so this can be adjusted, and for distributed point moment we need to adjust this. Here you can see now this moment is been showing here, so we can adjust this as per our demand, and let us click on apply and OK. Now here you can see all the three forces are being showing here. So after the loading has been assigned as per the given problem statement, we will go to this analysis option. Let us click on this analysis option. Here we need to define some commands regarding the analysis. So let us click on this define command tab, and in the analysis print command we will use this no print option. Let us click on this add, close, and in the post analysis command we will again click on this define command and we will add this analysis result, add and close. Here you can see two type of command has been added. Now we will click on this run analysis option. The structure has been modified, so STADD Pro will ask you to save this. Yes, click on the save, and the analysis will be done by the software. Here you can see we have 0 error, 0 warning, 0 note. So click on this view output file and done. So this is the output file of our problem. and we can directly double click on this analysis result. We will directly go to this line number 79. So here you can see this is the line number 79 and this is the analysis result. So these are the various forces, member end forces, and this is the support reaction. So let us close this here and let us click on this post processing. So when you will click on this post processing tab, and these two types of loads has been selected in our analytical modeling. Make sure that these two loads are in the selected window. Currently these two loads are already in the selected window. If these two loads are in the available window, make sure that you have to bring it to this window. Apply OK. Now this is the post processing, and we will look into these options one by one. So by default it opens in displacement. Let us maximize this window. So if you press your control key from the keyboard and rotate the wheel of the mouse, here you can see you will get a deflected shape of your structure. So I am rotating the wheel of the mouse in clockwise and anti-clockwise direction. So this can be adjusted by, make sure that when you are rotating the wheel of the mouse, you are also pressing the control key. So this is the deflected shape of your problem. Now if you want to know the value of the displacement, you need to go to this annotate option, and in annotate option click on this beam result, and in the beam result check this option, that is the displacement, and click on this annotate, close. Here you can see this is the displacement which is showing at this point, that is 0.887 mm. At this point it is showing 0.254 mm. Where here you can see this end was our fixed end, so there is no displacement, and this option is also checked here. Now if you click this displacement again, so displacement or the deflected shell will be switched off. If you again click on this, it will be on. Now if you want to click on this view loading diagram, then loading diagram will also be shown along with the deflected shell. So let us in order to generate report, we need to draw the loading diagram first. So let us click on the displacement tab here. So this is switched off and this is our loading diagram, and we will take the picture of it. Now if you want to also take the values of the loading diagram, so for that we can use the shortcut key, that is shift plus V. So if you press shift plus V, then this loading option will be showing here. If you again press this shift plus V, it will be switched off. So shift plus V is the shortcut key to open the loading values. So this is the loading diagram. Now I also want node to node distance. So for that I will go to this utility tab and press on this node tool and then go to the node to node distance. Now if I press on this to this is 5 meter, from this to this is 6 meter, and from this to this it is 4 meter. Okay, you can come out of the option by pressing the escape key. Now this is okay. Let us right click on here and take picture, and we will write here loading diagram, and in the caption we can also write loading diagram. Okay, now let us come here in the results, and let us close this loading diagram, and let us open on this displacement tab. Here you can see this is the deflected shape. Right click here, take picture again, and right here displacement. We can write here again displacement. Okay, So these two pictures we have taken, one is the loading diagram, another one is the displacement. Now click on this reaction. So these are the reactions that are getting generated at the particular node. We will go to this annotate tab first, and in the reaction option we can uncheck this global Z, because currently in the vertical axis, in the vertical loading case, we will not get any reaction in the Z direction. And bending, we can uncheck global Rx and global Ry. We can only get global Rz. And if you want to visualize this in a diagram, then check this option and give some scaling. Currently I am giving a scaling of 25, and annotate and close. Here you can see this is the reactions that are getting generated at a particular joints. So at this roller support you are getting 45.5 kilonewton. At this point we are getting 3.4. Here this is the fixed end, so you are getting a moment also of 5.5 kilonewton meter. Right click here, take picture. You can write here reactions. Okay, now let us click on this beam result. We will get various types of bending moment and shear force diagram. Now press your control key and rotate the wheel of the mouse. Here the bending moment diagram will get expanded in this way. So this is the bending moment diagram, and we need to know the values at a particular point. So for that, go to this annotate tab, and in the beam result check this option, that is at the ends, because we have a fixed end, we will get that bending moment here. And then click on this maximum, midpoint, annotate, close. Here you can see this is the bending moment diagram, and we are getting the values here. And again right click here, take picture, like BMD, and in the caption you can write bending moment diagram. Okay, now here you can see this MZ is on. Now if you close this MZ, the bending moment diagram will be switched off. If you again click on this, it will get on. Now let us close this first, and let us click this F5, because we will get a shear force in the Y direction. So this is the shear force diagram, and again press the control key and rotate the wheel of the mouse, you will get a shear force diagram. Now if I want to know the values, again we have to go to this annotate tab, and in the beam result you have to check these options. Okay. So these are the values of shear force diagram. Right click here, take picture, SFT, we will write here shear force diagram. Okay, close. So most probably we have taken all the options. Now we will go to this report, and in the report, for the reports, click on this setup report. So in the report setup option, input file, we will get the job info by default. Click on this output file. In the output file we want some detail information. So for that we want beam maximum moment, and we want reactions, and we can add anything as per our requirement. We can get this nodal displacement, beam displacement detail, and again from this out we can drop down, we can go to this picture, we can select all of them by clicking on this double arrow. So by clicking on this double arrow we will get all of them. Now if we want to relocate the options available, we can do it from these two arrows. So for an example, I want a loading diagram at the top, so I will bring this here, and then we can get this reactions. We can come here, this reaction we can bring it after reactions, and beam displacement detail we can bring it over here, then displacement picture we can bring it over here, then we can be maximum moment, BMD, SFD and BMD. So we can bring SFD over and BMD below. Okay, so this is okay. We can click on this OK. So here you can see this is the report that has been generated. We will go to this print option and we will save this as a PDF file at a particular location. So here you can see this I have saved here. We can write here continuous beam, save. So a report will be saved here. So here you can see this is the loading diagram. We can move to next page. This is the reactions and this is the reaction forces. In the next page we are getting beam displacement, we are getting this is the deflected shape, we are again have a table of maximum moments, we are getting the shear force diagram, moment, bending moment diagram. So after this, let us close this. So we have analyzed our problems and we have seen the report also. We have seen the bending moment and a shear force diagram, the deflected shape and all. Now we will move to this design part. So right now if you double click on any one of the beam, for an example, if you select this beam of span 6 meter, double click on this. Here you can see this these are the different properties of the beam. So first you will get the geometry property, you can get area of cross sections, moment of inertia, the loading. We have two different types of loading, that is the live load and the dead load. Here you can get the bending moment diagram for various types of loading. For live load you will get a different bending moment diagram, for dead load you will get a different bending moment diagram, deflection and all. Currently the deflection is open in X direction, so you will not get any deflection. Just check on this Y direction, you will get the deflected shape. But we are not getting any options of concrete design here. So it is because we have not given the command of design yet. So we will give those command first and then we can see the design part of the beam. So first close this tab and go to the analytical modeling again, and in the analytical modeling click on this option design. So when you will click on this option design, by default it opens in steel design. So what we are interested in concrete design, so we will check this option concrete, and in the concrete design the current code is IS456 by default. Now we have three different parameters here, that is first is select parameter, second is define parameter and third is the command. So we will be using all three of them one by one. So first click on this select parameter, and in the select parameter by default all the parameters are selected, but we will first unselect them, and whatever the command or the parameters we want in our design we will only choose them. So we want a clear cover from the bottom, this is required, and we want compressive strength of the concrete, we want yield strength of the main bar, we want yield strength of the shear reinforcement, and this is okay. Let us close this, and in the define parameters we need to give these values. So by clear cover it is 25 mm, it's okay. Let us don't change this. For FC we can write 20 Newton per mm square, but the unit here is kilonewton per meter square, so we will add 3 zeros. Add in FY we can use FE415, add 3 zeros. FE sec we can also use 415, we can add 3 zeros and close. Here you can see FC, FY main, FSEC main has been added, but there is a question mark in front of them. That means this has not been assigned here. So we need to assign them one by one. So first click on this FC, and this is for all the beams. So we will select them by dragging the mouse. So all the beam has been selected in one go, and we will check this and use assign to the selected beam, assign. Yes, here you can see the question mark has been removed and a green tick has been done. Now again select this all the three beams and check this option FY main. First check this and then select. So we will use this option assignment method. FY main has also been assigned. Similarly, use this FSEC, select this and assign this. So all the parameters has been assigned. Now we will move to this command, and in the command we want a design beam option and quantity takeoff close. So design beam option, again we have a question mark in front of it, so we will use check this first design beam. We will select all the beam because we want design for all the beam, and we will assign this. Now design commands have been assigned properly to all the options here. Now we will again move to this run analysis option. So in the run analysis option, computer will again ask you that the structure has been modified, whether we want to save it. Yes, we want to save it, and here you can see we are again getting 0 error, 0 warning, 0 note. And first close this, and design has been done. Now we can move to the post processing tab, and in the post processing tab, in the beam result, double click on any one of the beam, you will get this concrete design option. Now just click on this concrete design option. Here you can see the STADD Pro has designed this beam as per the given loading condition. So at the bottom we are getting 5 bars of 10 mm dia. At the top we are getting 5 bars of 10 mm dia, and the shear reinforcement we are getting 8 mm center to center at a distance of 200 mm. So this is the design of this beam. Let us close this and let us click on this first beam, double click on this, then check click on this concrete design. Here you can see at the top we are getting only 4 reinforcement, at the bottom we are getting 5 reinforcement. So this is as design has been done as per the Indian Standard Code. Here I want to discuss one thing with you all. Just click on this post processing and double click on any one of the beam, and in the concrete design, here you can see the STADD Pro has designed as per Indian Standard Code, and it has assigned 5 bars of 10 mm dia at the top and 5 bars of 10 mm dia at the bottom, and the shear reinforcement is of 8 mm dia. Now if you want to change the dia of the bar as per your availability, you can also do this. So for that you need to first close this design part, and you can go to this analytical modeling, and in the analytical modeling go to this design tab, and in the design tab first go to this select parameter, and in the select parameter first uncheck this all, and you can add, okay, this is for concrete. So for in the select parameter first uncheck this all, and we can add this clear cover. First we can add this FC, we can add FY, and we can add FSEC. Now these two are very important, that is the main bar, minimum size of the bar, and maximum size of the bar combination. So let us add this MD1 and MD2 also, and then close. And in the define parameter we need to define all of them. So here concrete cover is 25 mm, it's okay. FC we can again write 20, add 3 zeros, add FY we can add 415, 3 zeros, add FSEC we can also write F15, 415, 3 zeros, add. Now this MD1 is the minimum bar, main bar minimum size. So let us restrict up to 12 mm, add, and maximum we can also restrict to 16 mm, add, close. Now we need to again assign this manually to all of them. So FC, let us select this first, FC, assign, again select this first, select all the beams, assign, FSEC 415, select this, assign. Now MD1, let us first select this, select all the beams, assign, again select this, assign. Now we have restricted the diameter of the bar to 12 and 16 mm. Now come to command file, and we will again add this designed beam option. Click on add, and quantity takeoff, click on add, close. Now this design beam, we again have a question mark, so we will design all the 3 beams. So select this beam, all the 3 beams at one go, click on this design beam and use this assignment method, click on assign, yes. Now we will again click on this run analysis option. The STADD Pro will ask you whether you want to save the modified file. Yes, click on the save tab, and here you can see the STADD Pro have modified and analyzed and designed the problem again. First close this and just go to the post processing tab, and in the beam result double click on any one of the beam, and then click on the concrete design. Here you can see, since we have restricted the diameter of the bar, so here now we are getting 4 bars at the top, 4 bar at the bottom of 12 mm. We have not restricted the diameter of the shear reinforcement, so it has been done as per the previous condition. But at the top here we are getting 12 mm dia, and at the bottom we are getting 12 mm dia. You can double click on the first beam again to see whether any changes has been done. Yes, this is the reinforcement detailing of the beam. So I hope you all are getting to this wonderful experience of STADD Pro Connect Edition. Do practice all the types of problems by your own, so you will get the confidence, and I hope you will learn and share your experience with me. For any assistance, for any problem, you may write on the comment box, we will discuss it. For any problem or any error you are getting, we will discuss it, and we will try to rectify those errors at by one go. So thank you all, thank you for understanding and learning experience. I hope you will get benefited from my lecture videos, and be ready for another type of problem of portal frame in our next videos. Thank you all.